So in 4.8, we're introducing the composition of a function. Now, composition of a function is usually taught right after finding inverses because literally what you can do is take one function and it's the input into another one. So in pre-calc, when I teach inverse, we go right into the composition and we say, okay, take your inverse function that you just found, put it back into your original function and see what the output is, and then take your original, put it into the inverse and see what your output is. And that's mathematically how you verify functions. That is the notation. It's an open circle, like an open dot in between the two letters naming the functions. So it's read F composition G, but what you'll want to write down is that. And what you should be able to tell, because you guys are used to the notation, is that function G is being dropped into F. So whatever, H, open circle G or something, H, G of X. The second letter is the one that's being dropped into the first one. So here's some examples.
Can you scroll for like 1 second? Okay, thanks.
Good?
Yeah.
Okay.
I like them.
Okay. So we have F, G, and H. The very first example is G of -3 is going to be dropped into F. So first, we need to do G of -3. So what is that? So maybe off to the sides you do G of -3, right? What do you get? You go -3 gets squared minus 2. -3 squared is 9. Minus 2 is 7. So what we really have now is, what is F of 7? Because when I put -3 into G, I get an output of 7. Now I do F of 7. What's F of 7? -2 times 7 plus 6. -14 plus 6 is 8. So we've done function notation already. Now it's just doing it maybe 2, 3, or even up to 4 times on one problem. -8. Sorry. -14 plus 6 is the -8. Thank you. H, G, H of 3. So put 3 into H first. So again, you might do some work off to the side. What is H of 3? Well, here's H, so it looks like the square root of 3 plus 1. What's 3 plus 1? 4, square root. So that's a 2. Now I'm going to put that back in right there, so what is G of 2? So now we're going 2 squared minus 2, which is 4 minus 2, or 2 for my final answer. Pretty straightforward. Function notation, take your time. Do what's on the inside first, and just start working your way to the outside. So if somebody's sitting near you, please look at this one. Show them your answer when you're done. Putting negative 1 into F first, negative 2 times negative 1 is positive 2 plus 6 is 8. So I'm going to take that 8 now and put it in for the H. Way over there, so I end up with square root of 8 plus 1, or the square root of 9, which is 3. 3? People agree?
Yep.
That's all we're doing.
That's so sad.
We're gonna do one or two of these, I guess. Use the functions above to write and simplify each new function. Now we don't have any numbers. We're actually gonna take the equation and put it into the other equation, and then see if we can simplify. So, scroll up a little bit so we can see the functions there. So, literally, we are going to take function g and put it into f. So here's function g, right? G, and we're going to drop it into f. So we're going to bring this x squared minus 2, and we're just going to put it right there. So I'll scroll up in a second. But it's negative 2. What do I write instead of writing x? I write the x squared minus 2 from that function, x squared minus 2. But f still has this plus 6, so we need to make sure we write plus 6. So if you look at it, you're taking the x squared minus 2 and literally dropping it on top of the x, so it replaces that whole thing. So it's still negative 2 times something. Well, what are we multiplying by that? So as we clean it up, because it says simplify each new function, that's negative 2x squared plus 4 plus 6, and so my final answer is negative 2x squared plus 10. Do you see the answer there? So I'm going to pause it. You're going to work on B and C. Do exactly what I did. If you agree with the person sitting next to you, I want you to come up here and write your answer. And I would like you to try and write it this way, where you show the different colors, like what's the function and what was being dropped in there, that switch colors when you drop it in there. And then I will we'll check answers. So those would be the two answers. That one should be up for B, and then this one is C. This one is just kind of, do you guys remember doing angle chases when you were in geometry?
No.
Well, to me these are it kind of reminds me of those, because you just sit there and you plug one in because you know this, then you know that. And, all right. If you do them in the right order, these are super easy. So go to the inside one. What does it tell you to do? Put 4 into g, right? So here's function g. 4 as an input means that it's really your x value. So when you look at 4 right there, what's the output?
Negative 1.
Okay, so negative 1 is my output. So
So then F.
So instead of saying g of 4, when I put it in there, I get an output of negative 1. That negative 1 now goes into f,
Which then it's 1.
which is right there. So what's your output?
1.
So take the number, put it into the function. Now remember, x is our input, y is our output. So let's do the second one here. Negative 3. Here's where negative 3 is for f. What's your output?
4.
So, if 4 is your input now, put that into g, what's your output? Negative 1. So, I'm going to pause it. to see if you guys can figure out what's happening in C and D. Work with somebody, check your answers with them.
I see where
Okay, here we go.
I see where this is going.
So I'm gonna take the 5. I'm going to plug it into function f. So when I take the 5 and I plug it into function f, it gives me the 0 as the output, right? So that becomes my input, and where do I put it?
Into G.
I put it into function g. When I put 0 into function g, I get -2. So that becomes my that was my output, now it becomes my input, and I put it in one last time into function f, and the very last output is
6. Last
up,
one.
up top, -2 goes to 6. So put it in, what do you get out? That goes into the next, just find the letter of the function. So what'd you get for D?
This is a lot easier than angel.
But just remind. What do you get? 0?
Yeah.
So if I put 0 into G, what do we get? -2. That goes into F. What do we get? 6. F. And then that goes back into G again, and I get
0.
0. Good. All right, we do this almost exact same problem in pre-calc. It's kind of a cool problem, but the point would be if you're sitting in a biology class and you run those experiments, to calculate how much bacteria is on your turkey sandwich, you're supposed to use these 2 functions. It depends on how long the turkey sandwich has been out of the refrigerator, because based on time, Newton's law of cooling and all that stuff, right? Things will go to the other temperature. So if your turkey sandwich is at 34 degrees and you set it out in a 70-degree room, the turkey sandwich will warm up to room temperature, right? Slowly, but it'll get there. So that's why it's only 0 to 3 hours. They're probably saying the sandwich will be at room temperature in 3 hours. So we're not going to do the whole composition. We're just going to take 1.5 and plug it into T. So what happens when you take this 1.5 and you plug it in right there? What do we get? What do you get?
6.
Don't forget to add your 2. Show them. Now we're supposed to take that 8 though and plug it into n, right? So once you get this output, it goes into function n. So I'm going to switch colors so you can see it. Big N of 8 is 20. 8 squared minus 80 times 8 plus 500. So carefully type that into your calculator. You can do it exactly as I see it. 20 parentheses 8 squared minus 80 times 8 plus 500. So if it's been out on the counter for 1.5 hours, it's about, I guess, 8 degrees Celsius. And 8 degrees Celsius means how many bacteria do we have on the sandwich? 1,140 yummy bacteria. Find the number of bacteria that are present in the food 8 hours after it is removed from the refrigerator. I don't really like that question. Because 8 doesn't fit the parameters of the problem, right? So we're going to switch, let's just switch this to 3. because that would be kind of the maximum number we're supposed to be plugging in. So find the number of bacteria after 3 hours. Now, some of you might think that if it sits out for another hour and a half, right, that maybe it doubled. Would that be a reasonable guess? That the bacteria is going to double? It's not a reasonable guess?
Yeah.
It's reasonable. But let's see what happens, right? Most of you probably can figure out it's not going to happen that way, but. All right, so what is the temperature after 3 hours? What did I just do? Why did I do 1.5? 3. Sorry. Not 1.5 again, 3. 4 times 3 is 12 plus 2 is 14. So my sandwich is now at 14 degrees Celsius. And then I can plug it into that same equation up above, 20, 14 squared minus 80 times 14 plus 500. How many yummy bacteria on the sandwich now? Type it in exactly as you see it.
$3,300.
What is it?
3,300.
So it more than doubled, right?
Oh yeah.
2,300 would have been the correct amount if it doubled. But so the growth rate now is, you can see, is much faster as the sandwich warms up. Bacteria has a certain point where it grows very well. Okay, last problem. Last problem. So with somebody sitting near you, pretend this is your test question. Find F inverse. I'm going to give you about 1 minute. I would like you to find F inverse.
So then don't we solve for y after that?
So I started by writing y equals, exchange my x's and y's. So now the solving part, subtract the 1 to the other side. Stay with me, divide by 4. Now, what do you have to remember when you get rid of y squared? So you're going to square root both sides. What do you have to remember? You have to remember your plus or minus. Now, here's what I'll say about this problem. Mathematically, we found that equation. Supposedly, that's the inverse function, right? Correct?
Yes.
So if we go to a graphing calculator, it would look like this. I have the square root of x minus 4 divided by 2, is it? Or what is this? Oh, x minus 1 all divided by 4, sorry. X minus 1, all of that's being divided by 4. That's all under the radical. So that's what one of the graphs looks like. But then you have to type in the second one. But you just put the negative in front and then you do the square root. Same thing. X minus 1 being divided by 4, and graph that. Does that pass the vertical line test?
Yes.
It does not. So is that, can that be an inverse function?
Oh yeah.
Can't be an inverse function, right? You could call it the inverse, but it's definitely not an inverse function. So when you graph this thing, it kind of looks like that. Does not pass vertical line test. So what happens mathematically is there's a thing called the 1-to-1 rule, which you are not gonna be responsible for. But you would actually take a horizontal line test in the beginning. This is a U-shaped graph, it's gonna hit twice, so it's not gonna be a function, or it's not horizontal, so it's not 1-to-1. So you wouldn't even go looking for the inverse function. But anyway, the process was there, but there is no inverse. Again, another worksheet that I hand out now, that's your homework, so